All right, so we're going to do the last one here. This third quiz on concepts. We'll take a look at it real quick and see how we do. We'll do best guess again. If the acceleration of an object is 0, then, well, if the acceleration is 0, it's at equilibrium. There's certainly no net force on it. There's also no changes in velocity. It might be moving because it could be moving but not accelerating, so we don't like this answer. The velocity can't be changing, so we definitely like this one. And the position curve definitely could be moving, so let's take a look at number 2. In these three graphs of the same event, which one is velocity? So this looks like something's just accelerating with a constant acceleration. So A would be our acceleration. The velocity would be changing in a regular way, so C would be our velocity. And B, you can see, has a little curvature to it. It's concave up, which means the acceleration is positive. And that little curve that we have there represents the position graph for B. So the velocity is C. What characteristics of a velocity curve will give the acceleration? That would be the slope. When a position graph is concave up, we know that the object, so that's this one here, we have a position that's concave up. We saw our acceleration was positive, and so we can say that the positive acceleration. It's tempting to think that it has to be speeding up, but that's actually not always true. Let's take a look at the slope of a position curve. The slope of a position curve is going to give us velocity. The average velocity and the average speed would be the same if it's moving in the same direction the whole time. So if we have to look for a path, it's always the same. Seems like a nice answer, but actually it isn't, because we need to make sure not only is it the path the same, but we need to make sure that it never actually turns around. Okay, so we want to have that one there. The slope of a velocity curve gives acceleration. In a positive direction is taken to be north, and the acceleration is positive, so the acceleration is north. The velocity, well, it could be either one, because the acceleration is not the same thing as velocity. You can have acceleration that goes in the same direction as the velocity, but you can also have accelerations that go in the opposite direction of the velocity, so it could still be either one. The area underneath the velocity curve is related to position. We need to be careful here, though, because it's technically the change in the position, since it's displacement. Number 10, from these graphs, we know that the object has, we already talked about this, we decided it was a positive acceleration, and that's not on here, but it is also a constant acceleration. So let's go with that one. Let's see how we did. Again, we'll be looking for best guess here. And a little later in the morning, more people are getting on the internet here. We'll see if it still works. And pull down. And it looks like we did okay again. Fantastic. Thanks for listening. Hope it helped.